Okay, so this BTEC Sport and Exercise Science video is for Unit 2 Functional Anatomy. We are focusing on the skeletal system and specifically D2, the process of bone remodeling. So we've already had a video that explains how bones grow, convert cartilage into hardened, tough bone, and then once we reach physical maturity, we remodel through the rest of life. And this video is specifically on the remodeling process. So once we get up to our mid-20s, these epiphyseal plates, these growth plates that are in pink on this left-hand diagram, while we're growing, those are active growth sites where ossification happens. And as I said, that occurs till around your mid-20s, possibly going into your 30s. We can actually see an active epiphyseal plate or growth plate over here on this X-ray. So you can see there's a gap between the two sort of parts of bone, and that would be filled with cartilage, which doesn't show up on the X-ray. At physical maturity, so once we stop growing, these plates actually ossify themselves and become epiphyseal lines, so they become solid bone. No more bone growth, no more bone lengthening happens at those sites when we're physically mature. And you can see on this right-hand X-ray here, you see there's a solid line there instead of the gap. So when we stop physically growing and getting longer in the bone and literally getting taller, and we're physically mature, we do still have bone activity. There is still bone remodeling, and bone remodeling happens throughout life. You can see, again, going back to this diagram here, as we are born and grow, we have this boost in our bone density, the amount of bone mass that we've got. We get to our peak where our bones have pretty much fully grown. Late 20s, early 30s maybe. That's our modeling phase, growth phase. Kind of here we try and maintain that, maybe a maintenance phase, but actually you can see fairly clearly that as both males and females age, get older, we decrease in skeletal mass or bone density. And you can see that females unfortunately drop off even more because of menopause and the change of hormones happen there. But from that point of physical maturity till the end, that's our remodeling. That's what bones do. So what do we mean by bone remodeling? Well, these three bone cells that hopefully you already are aware of are actively degrading and rebuilding our bones. It's not instantaneous, it happens over a couple of months, this cycle of breaking down and rebuilding, breaking down, rebuilding. So as you can see, it happens as a cycle, a process, but it does happen throughout the bones of the body. Just to remind you then, we've got osteocytes, which are mature osteoblasts. They get trapped in the bone themselves. They become osteocytes. They then eventually kind of take charge. They control the activity of osteoblasts and clasts. Their job, their function is to maintain bone density and keep this remodeling process happening. They control remodeling. So the osteocytes are in charge. They're the foreman, if you like. Osteoclasts are the workers that clear out, break down, degrade, clear away the old bone. And then the osteoblasts come in and deposit collagen and calcium and phosphagen and lay down new bone. So again, it's this interrelationship between not only the osteocytes being in charge, but these two active bone cells. Just to give you a sort of visual perspective of it, this is where we're growing. So osteocytes are in charge. When we are growing, there is more osteoblast activity than there is osteoclast activity, i.e. we're building more new bone than we are degrading old bone or cartilage. That's because we're growing, we want more build. Our bones are getting longer, we need the imbalance in the good way. In the sort of middle bit of life, 20s, 30s, we are sort of in remodeling, but we're trying to maintain our bone density. So this is where we gain our bone density, and this is where we try to hold on to it. And the relationship between the activity of those two cells is more even. I'm not saying it's absolutely even, but it's more even. But as we age, unfortunately, hormone levels change. Men lose testosterone, women lose estrogen, plus I'm sure other hormones that influence like thyroxine. And the sex hormones, the imbalance of bone cells happens unfortunately in the wrong way, in the bad way, in that there is more osteoclast activity than there is osteoblast activity. And what that means is we're breaking down and degrading more bone than we are replacing. And that's a problem, and that can lead to issues like weak bones and osteoporosis. Here's just another visual of that same sort of graph, actually just showing the growth, age, the growth phase, the sort of peak levels, trying to maintain it, but as we age, we lose. Men lose less, women definitely lose. But we can do stuff about this with our diet. We will still lose bone density as we age, but with the right kind of exercise and the right kind of nutrition, we can reduce how much we lose. So what things can influence bone density then? There are 5 things that I want to make you aware of, a couple of which I've already mentioned. And I've put this acronym up here, HMBCE, just to prompt you. So H is for hormones. And hormones are part of the endocrine system. Now, in anatomy, we won't study that any more than now. We might need to learn about adrenaline at some point, but that's really all we do with the endocrine system. In the physiology unit, if you're doing the double course, we'll learn more about the endocrine system. But the endocrine system is basically a load of glands around our body, and glands release hormones. Estrogen, testosterone, human growth hormone, thyroxine all influence bone density. Of course, estrogen, testosterone, and probably growth hormone are the more common ones that you might know about, but it would be great to know what glands they come from as well. All of these boost osteoblast activity, which obviously is important for growing bones and maintaining bone density. As we've said already, as males and females age, they lose or have less of these hormones, and that causes an issue and an imbalance in the activity of osteoblasts and clasts, and therefore can influence bone density. So the next one, M, is for minerals. Hopefully already you know that calcium is the most essential mineral, not only for bone density, but it's stored in our skeleton for other processes like muscle contraction. Phosphorus is another mineral that we must have for healthy bones. And these minerals are stored in the skeleton, in the long bones. We get calcium from our diet, from things like dairy products, nuts and beans. Remember dairy, because dairy is quite a common source of these good things for bone. So that's the M, minerals. Next we have vitamins. Now the vitamin D is the most important one to remember. I've put these big and high and bold because these 2 are specifically mentioned in your specification. Vitamin D is important because it kind of helps our bones store more calcium. So having lots of vitamin D in your body helps your bones store calcium, and we know calcium is essential. So it really indirectly helps bone density. And we get vitamin D from exposure to natural sunlight, and so you need to get outside daily, but also from dairy products. So again, if you can remember dairy products, that's a good place to start in terms of diet. Just worth mentioning as well, things like vitamin C are beneficial for helping to make collagen, and that might be a way of remembering. C for collagen, and we get it from fruit and veg. And vitamin A is also really helpful in stimulating osteoblast activity. But calcium and vitamin D are specifically mentioned on your specification. So that's the V, HMV we've done, and we're on to C, collagen. Collagen is a fibrous protein. It glues things together. You can see that translated in Greek, kolla is glue and gen is producing. So collagen is like a glue producing protein. It binds the bones together to make them strong. It binds a lot of our tissues together to keep them strong, okay? Whether that's tendons or ligaments or our skin actually. So collagen is really important as a strengthening agent, and it's a fibrous protein. We get it from dairy. If in doubt, remember dairy. The last one of these factors that you need to know about is exercise. Now, it's not just any old exercise. It is load or weight bearing exercise and resistance exercise. Now, what that means is something like swimming is not load or weight bearing because you're floating, you're having no stress, no load, no impact being put down through your bones. You're buoyant. So, swimming actually isn't that beneficial in terms of bone health. So, what we want is walking, jogging, football, basketball, netball, where your load, your weight, and impact of contact with the ground is putting some level of what we call mechanical stress through your bones. So, stress is not a negative thing. Stress is necessary for positive adaptations. For example, if you go to the gym and you work your muscles a little bit harder each time, you are stressing them, you are making them challenged. And what we do with weight bearing exercise or resistance exercise using weights, you stress your bones, you create extra tension going through them or impact going through them, and that mechanical stress causes micro damage, a little bit of damage to the bone tissue. Now, when your bone tissue gets a little bit damaged, what it does is it rebuilds itself, but rebuilds itself a little bit stronger, and therefore more calcium is laid down, more new bone, more osteoblast and clast activity happens, and ultimately your bones become more dense. So the stress when we do weight bearing activity or resistance activity stimulates or makes osteocytes do more bone remodeling, more osteoclasts clearing out the damage, more osteoblasts laying down new calcium and collagen to make our bones stronger and more dense, which is a good thing. And just to give you a sort of extra additional bit of knowledge, that mechanical stress relationship, stressing our bones so that they grow stronger, is called Wolff's Law. Lastly then, just to look at the consequences, if we don't eat the right things, do the right kind of exercise, challenge our bones, make them stronger, we run the risk of something called osteoporosis. And what that means is instead of our bones looking like this top image, so this is cancellous bone with the holes that are supposed to be there, and then the strong bone that's supposed to be there. And if we end up having less dense bones, they look a bit like this. We've got the holes that are supposed to be there, but we've also got very holy bone, and that means it's weak, it's quite porous. That's where the name comes. Porous means it's got holes in it. So osteoporosis is a condition which is puts you at risk basically. It's where we lose more calcium than we should. Could be because of aging, it could be because of poor diet, it could be because of no stress and exercise, but basically our bones lose calcium. We have got more osteoclasts clearing out that calcium than we have blasts laying down the calcium. And the trouble with that is we are vulnerable. It could be because of hormone changes, as I said, going through middle age and onwards. But what in practice it actually means is we've got more osteoclast activity than we have osteoblast activity. We've got more resorption of calcium than we have deposition of calcium, and that's a problem because it will make our bones less dense. It will decrease our bone mass, makes the bones more porous, remember, more holy, and we are more likely to, if we bang our bones or fall, we're more likely to fracture them, and that's a huge risk. So let's have a look at questions that may link to this. So this question is for 4 marks, and it says, here are the 3 bone cells, types of bone cells. They help remodeling, so it gives you that information. What it wants from you is to state the role of each of the different bone cells in the process of bone remodeling. So use your knowledge of these 3 bone cells to explain the process of bone remodeling for 4 marks. And here's the mark scheme. State what osteoblasts do, state what osteoclasts do, state what osteocytes do, that's 3 marks, plus some extra knowledge to earn the 4th. So how do osteocytes become osteocytes? Osteoblasts get trapped in the bone matrix. They are mature osteoblasts. They get trapped and become osteocytes. Osteocytes are in charge, remember. Their job is to maintain bone density and strength. Their job is to direct the osteoclasts and tell them where to go and do bone remodeling. Here's another question. gives you information. Bone remodeling is a lifelong process. It renews skeletal tissues on a regular basis every couple of months. Explain the role of osteoclast and blast during bone remodeling. It doesn't want to know about osteocytes this time. This is easier, so for 4 marks you'd get 2 marks and 2 marks. And here is the mark scheme. You can see that it's fairly similar. Class breakdown, resorption of calcium and acid to break down the old bone. Blasts form or build new bone by depositing calcium and collagen. So that is it for D2, the process of bone remodeling. Remember, we did bone growth earlier. This is the remodeling content that we did. What is bone remodeling and what minerals are important? And bizarrely, your specification has put calcium, which is correct, but vitamin D, even though they've only talked about minerals. It's obviously a vitamin.